Hey everybody, Mr. Right here again. Obviously not here today. So I wanted to go over today what we're doing, expectations. All right, so first, I want you to look at these images and make some observations about these three objects. This one. What are some similarities and differences between these objects? And what do you already know about them? One similarity I can think of is that they're all solids. I see lots of differences. This one's very shiny. Kind of looks like a diamond. This one doesn't look like a diamond at all. This one has some shiny parts. What do I know are already about them? I'm pretty sure that's a diamond. Pretty sure. It's very shiny. This one looks like black powder. This one has a pencil next to it. So maybe this is graphite. Start of class today, where we are thinking about... Yeah! All right, so this one's graphite. Stuff you write with your pencil. Here's a diamond. And here's soot. And guess what? These are all made out of the same element, carbon. The same one. There's nothing more to it. It's just carbon. How is that possible? If they're all made out of carbon, but they look so different and their properties are so different, the thing that makes them look a certain way and have different physical properties is how the carbon atoms are structured. So as we can see in graphite, it's making these little rings, and then they're connected to another ring, and connected to another ring, and another ring, and another ring. Whereas we have diamond, and it's actually making a pretty cool cube. And then inside, there's other shapes. This might give it all of those shiny parts to it. Whereas graphite kind of looks dull. And then we have soot, and look, soot makes these sheets. And they're really flat. And they break apart really easily. Maybe that's why when you touch soot, it gets all over your fingers. But when I touch a diamond, it's very hard to break because it's a perfect cube. And then graphite kind of breaks off in these clumps. That makes sense. But all of those are made out of carbon, the same exact element. Our structures of carbon is that carbon atoms and carbon molecules, they can be oriented or structured in different ways. We have all sorts of things that we can make carbon out of. We can make graphene, fullerene, we can make a carbon nanotube, and also some graphite. Sometimes we use them in the medical field for medical delivery devices. If you wanted to bring medicine to different parts of your body, you might be able to put it into a ball of carbon and put it in your body, and it would get to where it needs to go. We could use them in conductors and also in electronics. So today, what I want us to be completing is we're going to complete the packet that we started yesterday. This is on making and building molecules. We took some notes yesterday on this front part, and then we also identified some chemical symbols. And then the latter half of yesterday, we got a chance to explore the PHET simulation, where we're building different molecules and naming them. When you're done with the rest of this packet, I want you to complete this page, naming that molecule. After you're done with this one, turning it in, and then the rest of your time, I want you to take a look at Bill Nye on atoms and molecules. All of these links are on Google Classroom. There's extra packets up front and you should have grabbed this one at the door. All right, so first what you're going to do is go to link number 7 in the hyperdoc. This is on Google Classroom. The link is there. Finish page 3 and 4 in the packet from yesterday, and then work on name that molecule. When you're done, turn both in. For work time, you can work by yourself or with a partner of your choice. I wanted to explain page 3 and 4 though first. So for page number 3, instead of going to the first tab that we did yesterday, see how it says first tab? You're going to go to the second tab. Many of you have already started this one from yesterday, but maybe you didn't finish. So your goal is to make certain molecules, draw them, and then identify the coefficient, the subscript, and then I want you to research. How is H2 used in real life? How is CO2 used in real life? How is O2 used in real life? You might have to Google this, you might have to look online. When you're on this multiple one, you're not doing single anymore. That was for this question. Now you're going to click on multiple. This is where you're going to be making multiple molecules together. For example, if you're making hydrogen, maybe you're making 4H2. You can make multiple of these. You can drag and drop our hydrogens up. And now I have H2, 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 H2. I have 4 groups of them. So I would call that 4H2. Aha, 4H2. You're going to bring them over here so that it tells you what you need to get for a goal. It tells you what you have and what you can get. You can also click on 3D to see an image of it. I'll show you that in a second. And that's what you could be drawing right here. All right, so that is that third page. When you get to this fourth page, page 4, fourth page, you're going to go to playground. So when you're at this playground, you can do multiple things here. So it says, can you make a molecule that can be broken into smaller molecules? All right. And we want to make something that's big. And what are the smaller molecules that it turns into? Next question is, what's the biggest molecule you can make? And then what is the second biggest molecule that you can make? So some tips in using the playground. As we start to put different molecules together with these atoms, you might notice something. There's no name. So it doesn't tell you the name, but maybe it lets you put them together. It doesn't give you an option for 3D or any more info about it. If that is showing up with no name, it's not a real molecule. It doesn't exist in nature. What you want is you want a name to show up like this. How you get that is you can click this button, and that'll break apart all of these atoms. So then it'll look like that. And I want you to try different combinations. The reason I had that as you are building your different molecules. Try different orientations or chains. Wait until the name pops up. Then it's real. So notice I was building this one. I built it, still no name. Then all of a sudden, I added one more hydrogen. So I added that hydrogen, and then all of a sudden, this name showed up. Now it's a molecule. Now it's real. And that's what I could use. After you're done with that whole page, the packet is done, everything's good to go. So think about that, you to turn that in. Then you're jumping over here to the page you grabbed at the door today. Look at each picture chemical name. So for example, let's do this one. So I'm looking at this picture, looking at this chemical name. My steps are, notice the elements. Oh, okay. I see an H and I see a Cl. All right. These are bonded together to make a molecule. Count the elements. Okay? So I got 2 of them, and the atoms involved are also 2. So I have 1 H, and I have 1 Cl. 1 hydrogen, 1 chlorine. Then write the chemical formula and use the correct subscripts. So I'm right over here, and I'm like, all right, H and a Cl. All right, H, C, L. Whenever you're writing them, the correct way to write them is if it has carbon first, or if the molecule has carbon, you write carbon first. So C first. This one doesn't have a C, so don't worry about it. And then H is next. C, H, and then everything else in alphabetical order. So if I find one with oh, here it is. I have carbon dioxide and a C and then 2 O's. So C is first and then an H, and there's no H here. So that's fine. I would write C, and then there's 2 O's. O, 2. All right. When you're done with this, both sides, you're turning that in. And then the rest of your time is you have a great rest of your day. I hope to be in school tomorrow. And for everybody who's in Lego Robotics, I plan to be at school for that this afternoon. So it's not canceled. I will be there for Lego Robotics today. All right. See you later. You watch it. I hope that Bill Nye that I've linked on Google Classroom.